हे गाइस वेलकम बैक टू माय चैनल। अपनी सीरीज़ चल रही सी पीएससी भी क्लास 12 फिजिक्स की ਉਹਦੇ ਵਿੱਚੋਂ मैं ਤੁਹਾਨੂੰ ਅੱਜ ਕਰਾਉਣ ਜਾ ਰਹੀ ਹਾਂ यूनिट 7 ਤੁਹਾਡਾ ਜਿਹੜਾ ਹੈਗਾ ਹੈ ਡਿਊਲ ਨੇਚਰ ਆਫ ਮੈਟਰ ਐਂਡ ਰੇਡੀਏਸ਼ਨ। ਇਹਦੇ MCQs ਕਵਰ ਕਰਾਂਗੇ ਅਸੀਂ ਇਸ ਵੀਡੀਓ ਦੇ ਵਿੱਚ। ਠੀਕ ਹੈ, ਇਸ ਤੋਂ ਪਹਿਲਾਂ ਮੈਂ ਸਾਰੇ ਤੁਹਾਡੇ 6 ਯੂਨਿਟਸ ਦੇ ਵੀਡੀਓਜ਼ ਪਾ ਚੁੱਕੀ ਹਾਂ। ਇਲੈਕਟ੍ਰੋਸਟੈਟਿਕਸ ਦੇ, ਕਰੰਟ ਇਲੈਕਟ੍ਰਿਸਿਟੀ, ਮੈਗਨੈਟਿਕ ਇਫੈਕਟਸ ਆਫ ਕਰੰਟ ਐਂਡ ਮੈਗਨੇਟਿਜ਼ਮ, ਇਲੈਕਟ੍ਰੋਮੈਗਨੈਟਿਕ ਇੰਡਕਸ਼ਨ ਐਂਡ ਆਲਟਰਨੇਟਿੰਗ ਕਰੰਟ, ਇਲੈਕਟ੍ਰੋਮੈਗਨੈਟਿਕ ਵੇਵਸ ਤੇ ਆਪਟਿਕਸ। ਹੁਣ ਮੈਂ ਤੁਹਾਨੂੰ ਕਰਾਉਣ ਜਾ ਰਹੀ ਹਾਂ ਡਿਊਲ ਨੇਚਰ ਆਫ ਮੈਟਰ ਐਂਡ ਰੇਡੀਏਸ਼ਨ ਦੇ MCQs। ਠੀਕ ਹੈ, ਤੁਸੀਂ ਮੇਰੇ ਚੈਨਲ ਦੇ ਉੱਤੇ ਪਲੇਲਿਸਟ ਵੀ ਚੈੱਕ ਆਊਟ ਕਰ ਸਕਦੇ ਇਹਨਾਂ ਦੀ। ਓਕੇ, ਆਪਾਂ MCQs ਵੱਲ ਮੂਵ ਕਰਦੇ ਹਾਂ। ਫਸਟ ਕੁਐਸਚਨ ਹੈਗਾ ਤੁਹਾਡਾ, ਵੇਵਲੈਂਥ ਆਫ ਮੈਟਰ ਵੇਵਸ ਇਜ਼ ਇੰਡੀਪੈਂਡੈਂਟ ਆਫ। ਵੇਵਲੈਂਥ ਜਿਹੜੀ ਮੈਟਰ ਵੇਵ ਦੀ ਉਹ ਇੰਡੀਪੈਂਡੈਂਟ ਹੈ ਕਾਹਦੇ ਤੋਂ? ਡੀ ਚਾਰਜ। ਇੱਥੇ ਆ ਜਾਊਗਾ ਤੁਹਾਡਾ ਚਾਰਜ। ਨੈਕਸਟ ਕੁਐਸਚਨ, ਵਾਟ ਇਜ਼ ਦ ਰੈਸਟ ਮਾਸ ਆਫ ਅ ਯੂਨਿਟ? ਇਹਦਾ ਆਂਸਰ ਹੈਗਾ B0। ਇਹ ਤਾਂ ਤੁਹਾਡਾ ਕੁਐਸਚਨ ਜਨਰਲੀ ਪੇਪਰ 'ਚ ਆ ਜਾਂਦਾ ਕਿ ਰੈਸਟ ਮਾਸ ਫੋਟੋਨ ਦਾ 2 ਮਾਰਕਸ ਵਿੱਚ ਪੁੱਛ ਸਕਦੇ ਆ, MCQ 'ਚ ਪੁੱਛ ਸਕਦੇ। ਰੈਸਟ ਮਾਸ ਫੋਟੋਨ ਦਾ 0 ਹੁੰਦਾ ਹੈ। ਨੈਕਸਟ ਕੁਐਸਚਨ, ਦੀ ਯੂਨਿਟ ਆਫ ਪਲੈਂਕਸ ਕਾਂਸਟੈਂਟ ਇਜ਼। ਪਲੈਂਕਸ ਕਾਂਸਟੈਂਟ ਦਾ ਯੂਨਿਟ ਹੈਗਾ D ਜੂਲ ਸੈਕਿੰਡ। ਓਕੇ, ਨੈਕਸਟ ਕੁਐਸਚਨ ਹੈਗਾ, ਇਲੈਕਟ੍ਰੋਨ ਵੋਲਟ ਇਜ਼ ਅ ਯੂਨਿਟ ਆਫ। ਇਲੈਕਟ੍ਰੋਨ ਵੋਲਟ ਕਾਹਦਾ ਯੂਨਿਟ ਹੈ? A ਐਨਰਜੀ। Next, the minimum energy required to remove an electron is called A work function. Next, 1 electron volt is equal to C 1.6 into 10 raised to minus 19 joule. Next, according to Einstein photoelectric equation, the graph between kinetic energy of photoelectron ejected and frequency mu of incident radiation is। ਇਹਨਾਂ ਚਾਰ ਗ੍ਰਾਫਸ 'ਚੋਂ ਆਪਾਂ ਦੱਸਣਾ ਵੀ ਕਿਹੜਾ ਸਹੀ ਆ। ਗ੍ਰਾਫ ਆਪਣਾ ਜਿਹੜਾ ਹੈ ਉਹ ਸਹੀ ਹੈਗਾ D। Okay, next question is, calculate momentum of photon. Frequency associated with the photon is 5 into 10 raised to 13 Hz. Given h ਦੀ value given है, h is equal to 6.6 into 10 raised to minus 34 joule per second ਤੇ velocity ਦਿੱਤੀ ਹੋਈ ਹੈ ਤੁਹਾਨੂੰ 3 into 10 raised to 8। ਆਂਸਰ ਇਹਦਾ ਹੈਗਾ B। ਇਹ ਤੁਸੀਂ ਸੋਲਵ ਕਰਕੇ ਦੇਖ ਲੈਣਾ। ਓਕੇ, ਨੈਕਸਟ, wavelength of radiation of frequency 100 Hz is। Answer is B 3 into 10 raised to 6 meter. Next question, wavelength of a particle having momentum 2 into 10 raised to minus 28 kg meter per second is A 3 into 3 into 10 raised to minus 6 meter. Next, what do you mean by dual nature of matter? Particle nature भी ते wave nature दोनों नहीं, मतलब कि both A and B. Next question, de Broglie wavelength lambda of an electron of energy E is given by relation. Answer is A lambda is equal to h upon under root of 2me. Lambda is equal to h upon under root of 2me. Next, two metals P and Q when illuminated with appropriate radiation emit photoelectrons. The work function of P is higher than Q. Which metal will have higher value of threshold frequency and why? Answer is A P. P ਦੀ ਹੋਏਗੀ ज़्यादा threshold frequency. Next है, what is the momentum of photon of frequency mu? Answer is B P is equal to h nu upon C. Next, an electron is accelerated through a potential difference of 300 volt. What is the energy in electron volt? Answer is A 4 into 10 raised to 8 4.8 into 10 raised to minus 17 electron volt. What is specific charge? Give its value in SI. Answer is A E upon M comma 1.76 into 10 raised to 11 C kilogram inverse. Next, what would be happen if electron becomes stationary in a atom? Answer is B it will fuse with nucleus. Next, calculate momentum of electron if their wavelength is 2 Armstrong. Given Planck's constant h is equal to 6.62 into 10 raised to minus 34 joule second. Mass of electron is 9.1 into 10 raised to minus 31 kg. A 3.31 into 10 raised to minus 34 kilogram per meter per second. Next question हैगा या, electron volt is the energy gained by an electron when accelerated under a potential difference of A 1 volt. Next, which photon is more energetic, a red one or a violet one? Answer is B violet one is more energetic. Next, what is the momentum of an electron of energy 100 electron volt? Answer is A. 53.99 into 10 raised to minus 25 kg meter per second. Next, name the unit for measuring the kinetic energy of electrons. Answer is B. Electron volt. Next, electron beam remain undeviated in external magnetic field. Answer is false. Next, the emission of electron is possible by photoelectric effect, thermionic emission, both A and B. Answer is C. Both A and B. The conversion of light energy into electrical energy is achieved in a photocell. Next, photoelectric effect shows B. Particle nature of light. Next, a photon behaves as if it has had a mass equal to D. H nu upon c square. Next, a photon of wavelength lambda can be associated to have a mass equal to B. H upon c lambda. Next, energy of a photon of frequency nu is C. H nu. Next, energy of a photon cannot be represented by B. H c lambda. Next, the energy of a photon of wavelength lambda is B. H c upon lambda. Next, the de Broglie wavelength of an alpha particle at V volt will be, answer is C. 0.101 upon under root of V into Armstrong. Next, X-rays were discovered by Röntgen. Next, the magnitude of saturation photoelectric current depends upon intensity. Next, a strong argument for the particle nature of cathode rays is that they C. Get deflected by electric and magnetic field. Next, when cathode rays are intercepted by matter, then heat is produced. Next question is, out of cathode rays, positive rays and alpha rays, the value of specific charge is constant for C. Cathode rays and alpha rays. Next, specific charge is least for A. Alpha particle. Next, central rays are C. A stream of positively charged particles. Next, air becomes conducting when the pressure range is between C. 1 cm and 10 raised to minus 3 cm. Next, in a discharge tube, ionization of enclosed gas is produced due to collisions between C. Negative electrons and neutral atoms, molecules. Next, in fluorescence, there is A. Increase in wavelength of emitted radiation. Next, Millikan-Aldrich experiment is based on D. Stokes' law. Next, the important conclusion given by Millikan's experiment about the charge is C. Charge is quantized. Next, the number of photoelectrons emitted from a metal surface depend upon the intensity of the incident light. Next, photoelectrons are emitted when answer is C. When zinc plate is irradiated with light. Next question, electron emission is possible from the surface of metal by D. All of the above. Heating the surface suitably, irradiating the surface with suitable light, and applying a strong electric field. Next, the photoelectric effect can be understood on the basis of answer is B. Quantum theory of light only. Next question is, the maximum kinetic energy of the emitted photoelectrons depend upon B. The frequency of the incident radiation. The maximum kinetic energy of the emitted photoelectron depends upon the frequency of the incident radiation. Next question है in Einstein's work on the photoelectric effect provided support for the equation A. E is equal to h nu. Next, the best material to be used for photo emission is D. Calcium. cesium, sorry. Next question, which phenomena among the following shows particle nature of light? D. Photoelectric effect. Next, the phenomena of photoelectric emission was first discovered by B. Heinrich Hertz. Next, photocell is a device. Answer is to measure intensity of light. Photocells are used to D. All of the above. Automatic switching of street light, operation of burglar alarm, reproduction of sound recorded on films along with pictures in the movie theater. Next, the stopping potential mu naught is D. Independent of the intensity of the incident light. Next, the phenomena inverse to photoelectric effect is D. Production of X-rays. Next, in photoelectric emission, the velocity of electrons ejected from near the surface is A. Larger than those coming from interior of metal. Next, the number of photoelectrons emitted from light of frequency mu higher than threshold frequency mu naught is proportional to B. Intensity of light. Next, maximum energy of the electron released in a photocell is independent of B. Intensity of incident light. Next, the photoelectrons emitted from a surface of sodium metal are such that D. They have their speeds varying from 0 to a certain maximum. Next, the velocity of photoelectrons emitted from a metal surface D lies between 0 and finite maximum value for all photoelectrons. Next, a photocell converts light energy into electrical energy by C. Developing an EMF. Next, a photoconductive cell converts light energy into electrical energy by B. Decreasing resistance. Next, the slope of frequency of incident light versus stopping potential for a given surface will be A. H upon E. Next, to understand photoelectric effect, a graph is plotted between two factors which is a straight line. The factor are A. Intensity of radiation and photoelectric current. Next, which of the following phenomena support wave nature of light? Answer है D. Diffraction of light. Next, which phenomena supports the concept that the matter has a wave nature? B. Electron diffraction. The dual nature of light is exhibited by A. Diffraction and photoelectric effect. Next, Compton, Compton effect is associated with A. X-rays. Next, the maximum kinetic energy of the photoelectron depends upon D. Frequency. Next, in photoelectric effect, the number of photoelectrons emitted is proportional to A. Intensity of incident beam. Next, X-rays are used to irradiate sodium and copper surfaces in two separate experiments and stopping potential determined. This stopping potential is B. Greater for sodium. Next, sodium surface is illuminated by UV and visible radiation successively and the stopping potential determined. This stopping potential is B. More with UV light. Next, the Planck's constant is dimensionally equal to angular momentum. Next, the number of photons required to give a definite energy varies inversely as the frequency. Next, the value of 1 m electron volt is C. 1.6 into 10 raised to minus 13 joule. Next, a proton is about 1890 times heavier than an electron. When it is accelerated by a potential difference of 1 kilovolt, its kinetic energy will be A. 1 kilo electron volt. Which of the following is not the property of cathode rays? D. They do not deflect in electric field. Next, an electron and a proton have same deep Broglie wavelength. The kinetic energy of electron is A. Infinite. Next question. If an electron and a photon propagate in the form of waves having same wavelength, it implies that they have the same c momentum. Next, light of wavelength 5000 Armstrong is incident on a metal whose work function is 2 electron volt. The maximum kinetic energy of photoelectrons would be. Answer is D, 0. 0.5 electron volt. Next question. An electric field of intensity 6 into 10 raised to 4 volt per meter is applied perpendicular to the direction of motion of the electron. A magnetic field of induction 8 into 10 raised to minus 2 Weber per meter square is applied perpendicular to both the electric field and direction of motion of the electron. What is the velocity of the electron if it passed undeflected? Answer is A, 7.5 into 10 raised to 5 meter per second. Next, the ratio of specific charge of ionic deuterium to that of proton will be. Answer is D, 1:2. Next, cathode rays of velocity 10 raised to 6 meter per second describe an approximate circular path of radius 1 meter in an electric field of 500 volt per centimeter. If the velocity of cathode ray is doubled, the value of electric field needed so that the rays describe the same circular path is C, 2000 volt per centimeter. Next, a charged particle is moving in a uniform magnetic field in a circular path. The energy of the particle is tripled. If the initial radius of the circular path was r, the radius of the new circular path after the energy is tripled will be d, r into under root 3. Next, an oil drop of mass 50 milligram and of charge minus 5 microcoulomb is just balanced in air against the force of gravity. Calculate the strength of the electric field required to balance it. Answer is B, 98 Newton per coulomb downwards. Next, a charged oil drop of mass 9.75 into 10 raised to minus 15 kg and charge 30 into 10 raised to minus 16 coulomb is suspended in a uniform electric field existing between two parallel plates. The field between the plates is D, 32 into 32.5 volt per meter. Next, a charged oil drop is suspended in a uniform electric field of 3 into 10 raised to 4 volt per meter so that it neither falls or rises. The charge on the drop will be. Answer is B, 3 into 3.234 into 10 raised to minus 18 coulomb. ਬਾਕੀ ਸਾਰੇ ਤੁਹਾਡੇ ਮੈਨੂੰ ਲੱਗਦਾ numerical ਹੀ ਆ. Next is an oil drop of mass 100 mg of charge 10 microcoulomb is just balanced in air against the force of gravity. Calculate the strength of electric field required to balance it. Answer is B, 98 Newton per coulomb downwards. Next, if work function of metal surface is 2 electron volt, its threshold wavelength of radiation is D, 6188 Armstrong. Next, the threshold wavelength for photoelectric effect on a metal corresponds to 6000 Armstrong. Its work function is B, 3.3 into 10 raised to minus 19 joule. Next, the lowest frequency of light that will cause the emission of photoelectrons from the metal surface for which the work function is 1.65 electron volt will be C, 4 into 10 raised to 4 into 10 raised to 14 Hz. Next, the work function of a metal surface is 4.2 electron volt. The maximum wavelength which can be eject electrons from this metal surface is C, 2946 Armstrong. Next, if a surface has a work function 3.2 electron volt, the longest wavelength of light which will cause the emission of electrons is B, 3867 Armstrong. Next, if work function of metal is 3 electron volt, then threshold wavelength will be A, 4138 Armstrong. Next, A photon of energy 4 electron volt is incident on metal surface whose work function is 2 electron volt. The minimum reverse potential to be applied for stopping the emission of electrons is A. 2 electron volt. The energy of photon of light of wavelength 415 nm is A. 4.4 into 10 raised to minus 19 joule. Next, what is the momentum of a photon having frequency 1.8 into 10 raised to 13 Hz? Answer is C. 4 into 10 raised to minus 29 kg meter per second. Next, energy of a photon corresponding to the visible light of maximum wavelength is approximately B. 1.6 electron volt. Next, an X-ray has a wavelength 0.02 Armstrong. Its momentum is C. 3.3 into 10 raised to minus 22. Next, a radio transmitter operates at a frequency 1000 kHz and a power of 66 volt kilowatt. Find the number of photons emitted per second. Answer is C. 10 raised to 29. Next, in photoelectric effect, the photoelectric current is independent of frequency of incident light. Next, if an electron and photon propagate in the forms of wave having the same wavelength, it implies that they have the same momentum. Next, as the intensity of incident light increases, a photoelectric current increases. Next, which of the following is correct? C. Photocurrent. The photocurrent increases with intensity of light. Next question. The photon of frequency nu has a momentum associated with it. If c is the velocity of light, then momentum is d. H nu upon lambda, h nu upon c. In a photoelectric experiment, if both the intensity and frequency of the incident light are doubled, then the saturation photoelectric current is doubled. Next, a photoelectric cell is illuminated by a point source of light 1 meter away. When the source is shifted to 2 meter, then answer is D. Number of electrons emitted. Number of electrons. Number of electrons emitted is a quarter of the initial number. Next, light of wavelength lambda falls on a metal having work function Hc upon lambda naught. Photoelectric effect will take place only B. Lambda is less than equal to lambda naught. Next, the photoelectric threshold frequency of a metal is nu. When light of frequency 4 nu is incident on the metal, the maximum kinetic energy of the emitted photoelectron is B. 3h nu. Next, which of these particles have the same kinetic energy has the largest de Broglie wavelength? Answer is A. Electron. Next, a proton and an alpha particle are accelerated through the same potential difference. The ratio of de Broglie wavelength lambda p to that of lambda alpha is, answer is D, under root 8 ratio 1. Next, if the kinetic energy of a free electron doubles, its de Broglie wavelength changes by the factor C, 1 upon under root 2. Next, the best material to be used for photo emission is D, cesium. Next, the threshold wavelength of sodium metal is 6800 A. The work function is A, 1.82 electron volt. Next, photoelectric current can be increased by using B, higher intensity radiation. Next, a proton and alpha particle are accelerated through the same potential difference. The ratio of their de Broglie wavelength will be D, 2 root 2 ratio 1. Next, the wavelength of an electron of energy 120 kilo electron volt will be A. 0.12 Armstrong. If photon and electron have same de Broglie wavelength, then electron has more kinetic energy than proton. Next, if we consider electrons and photons of same wavelength, then they will have the same d momentum. Next, the mass of photon at rest is 0. ठीक है, ਇਹ ਸੀਗੇ ਤੁਹਾਡੇ ਸਾਰੇ MCQs ਯੂਨਿਟ 7 ਦੇ। 2 MCQs ਹੋਰ ਹੈ, 2 ਹੋਰ ਇਹ ਵੀ ਦੇਖ ਲਓ। When a proton is accelerated with 1 volt potential difference, then its kinetic energy is C, 1 electron volt. Next, 1 million electron volt is C, 1.6 into 10 raised to minus 13 joule. ठीक है, ਇਹ ਸੀਗੇ ਤੁਹਾਡੇ ਸਾਰੇ MCQs। ਆ ਦੇਖੋ ਥੱਲੇ ਆਨਸਰ ਵੀ ਗਿਵਨ ਨੇ, ਤੁਸੀਂ ਸਕਰੀਨਸ਼ਾਟ ਲੈ ਸਕਦੇ ਹੋ ਇਹਦਾ। ਠੀਕ ਹੈ, ਸੋ ਇਹੀ ਸੀਗਾ ਆਪਣਾ ਅੱਜ ਦਾ ਵੀਡੀਓ। ਜੇਕਰ ਤੁਸੀਂ ਵੀਡੀਓ ਤੋਂ ਇੱਥੇ ਤੱਕ ਪਹੁੰਚੇ ਆ ਤਾਂ ਕਮੈਂਟ ਕਰਕੇ ਜਾਣਾ ਨਾ ਭੁੱਲਿਓ। ਵੀਡੀਓ ਨੂੰ ਲਾਈਕ ਵੀ ਜ਼ਰੂਰ ਕਰਿਓ ਅਤੇ ਚੈਨਲ ਨੂੰ ਸਬਸਕ੍ਰਾਈਬ ਵੀ ਕਰਿਓ। ਇਸ ਤੋਂ ਬਾਅਦ ਮੈਂ ਕੈਮਿਸਟਰੀ ਦੇ ਸਾਰੇ ਵੀਡੀਓਜ਼ ਇਸੇ ਚੈਨਲ ਦੇ ਉੱਤੇ ਅਪਲੋਡ ਕਰਾਂਗੇ, PSCB ਕਲਾਸ 12 ਤੇ। ਠੀਕ ਹੈ, ਅਤੇ ਤੁਹਾਡਾ ਕੱਲ੍ਹ ਨੂੰ ਹੈਗਾ ਆ ਫਿਜ਼ਿਕਸ ਦਾ ਪੇਪਰ ਚੰਗੀ ਤਰ੍ਹਾਂ ਪਾ ਕੇ ਆਇਓ। MCQs ਦੀ ਸਾਰੀ ਪਲੇਲਿਸਟ ਸਾਡੇ ਚੈਨਲ ਦੇ ਉੱਤੇ ਪਈ ਆ। ਜੇਕਰ ਤੁਹਾਨੂੰ ਵੀਡੀਓ ਚੰਗੀ ਲੱਗੀ ਹੋਵੇ ਤਾਂ ਲਾਈਕ ਸ਼ੇਅਰ ਸਬਸਕ੍ਰਾਈਬ ਜ਼ਰੂਰ ਕਰਿਓ। ਓਕੇ, ਅਤੇ ਇੱਕ ਕਮੈਂਟ ਜ਼ਰੂਰ ਡਰੋਪ ਕਰਿਆ ਕਰੋ ਤਾਂ ਕਿ ਸਾਨੂੰ ਇਨਕਰੇਜਮੈਂਟ ਮਿਲੇ, ਅਸੀਂ ਹੋਰ ਵੀ ਅਜਿਹੇ ਵੀਡੀਓਜ਼ ਪਾਈਏ। ਠੀਕ ਹੈ, ਅਤੇ ਇਸ ਤੋਂ ਪਹਿਲਾਂ ਵੀ ਮੈਂ ਸਾਰੀ ਯੂਨਿਟਸ ਦੇ ਵੀਡੀਓਜ਼ ਪਾ ਚੁੱਕੀ ਹਾਂ, ਤੁਸੀਂ ਕਾਈਂਡਲੀ ਉਹ ਪਲੇਲਿਸਟ ਚੈੱਕ ਕਰਿਓ। ਓਕੇ, ਥੈਂਕਸ ਫॉर ਵਾਚਿੰਗ, ਬਾਏ ਬਾਏ।